Hello guys, my name is Balkrishna Srivastav and welcome to CodeWithBK. So in this video, we write a Java code to write rotate a linked list by k places. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. And one more thing before we start is that I teach coding in Hindi as well on a separate Code with BK Hindi channel. So if you guys are comfortable with Hindi, it is a request if you could spare 5 minutes and check out this channel. Let me know your thoughts, reviews about this channel in the comments as well. Alright, so we are given a linked list and we will have to rotate it by k places. I've already posted a video for left rotation. You can find the link of the video in the description of this video. Okay, so this is the node class that we are using. The data is integer and you can have any kind of data here. This is a reference to the next node and this is what creates the link in our linked list. So we have to complete this function that takes the head of the linked list and the value k, rotates this list right by k times and returns the head of the rotated list. Alright, so what do I have to do is, if I'm given a list, say 1, the next of the last node is supposed to be null. Okay, I have to write rotate k times. Okay, so I'm going to apply two approaches to this. The first one is brute force. The second one is optimized. Okay, if you guys don't want to know what this brute force approach is, okay, you can directly skip to the optimized approach. So brute force approach is finding a way to write rotate the list once. So write rotate once. So if we are able to write a Java function that rotates the list right once, we can call the function k times and do it k times. Do it is not the right English, but let's go with this. Okay. Alright. So I have to rotate it, write rotate once. Okay. So the list that I'm supposed to get by right rotating it is this goes right, this goes right, this goes right, and this goes right. Okay. 27 when goes to right goes out of the boundary, so it goes to the other side. Okay, rotates to the other side. Okay, so the list that you get by right rotating this list once is 27 comes from the last to the first, then the remaining list 1, 3, 12, 18. Okay, and null. Okay, if we are able to find the code to do this, we can run this code k times and it will give us right rotation k times. Okay, now how do we do this? So let me just write this original list again. So I need to get my last node to the front. That's the idea. From this list, I need to go to this list. Alright, how do I get my last node to the front? I will say first you have to find last node. Okay, so this is the last node and we store it in a separate variable last node. And this eventually will be the new head of our rotated linked list because 27 is the new head which was at the last of the original linked list. Okay, second is find second last node. Okay, why do we need to find second last node? Because if this is the last node, this is my second last. I will have to disconnect this 27 from the remaining list. So I'll have to set the next of 18 to null and then I move this 27 node to the front of the linked list. So that's why I need this second last node as well. Okay, then I do disconnect a last node from the list. Okay, that's what I said. That's why I need the reference to this second last node. So that I said 18's next to null, I disconnect 27 from the remaining list. And then I move last node to the front of the list. Okay, forgive me for my handwriting. It has always been horrible. Okay, and fifth is returning the new head. Okay, which is basically your last node only. Okay, this 27 is a new head, which is the last node. Okay, these are the steps that you need to do when you have at least two nodes. What I mean to say is, if your list is A, empty, that is head is null, so you return null. Okay, B has one node, it means head dot next is null, so you return head again. In that case, you return the same list. Because a list with one single node, you write rotate it as many times possible, it is going to be the same list. Okay, then comes the third case has greater than one node, so at least two nodes, in which case you do this. Okay, so I'm going to try run this and show this as well to you. So let me just write the code first. So this is to rotate k times. Let me write a function. Okay, write rotate linked list once. Okay, return the head, and the complexity is going to be on, right, because we'll be iterating the list once to find the last and the second last node. So right rotate once, so I don't need the value of k. The first part is if head is null, okay, if the list is empty, or head dot next is null, okay, we return head, return the list as it is, okay, this part a and b. Then we come to the part where we have to do these 5 points. So find the last node. So I say node current is head, and the standard code to find the last node is while current dot next is not equal to null. Okay, you say current is current dot next. Okay, I'll try and show this how this works. So when this loop ends, current is where current dot next is null, because that is where this loop is going to break. This condition is going to fall. This condition is going to be false. Current dot next is null for the last node only of the list. So I say saving the last node, which is current right now. Okay. Also, I need the second last node, which is right behind the last node. So I can create another variable. Okay, I'll say previous is null, which is going to tail my current. That is, my previous will always be the node behind current, because when current is head, previous is null. When I want to move current forward, previous is current. Okay, again, I'm going to try run this and show this to you. All right. So my second last node is going to be in previous. Okay, find the last node and the second last node. Okay, then what do I need is, I found last node, I found the second last node. I need to disconnect last node from the list. So I set the next of 18 to null, which is the second last node. So I set disconnect last node from the list. So I say second last node dot next is null. Okay, this point is done. Then move the last node to the front of the list. That is, this has to come at the front. So the old head has to be the next of the last node. So bring last node to the front of the list. That is, last node dot next is now my original head. Okay, and the final point, return the new head, return the new head, which is my last node itself. So I say return new head, which is last node. This is going to right rotate once. Okay, so let me just show this to you. Okay, so again, making my original list 1. All right, point 1, find last node, which is, and the second last node, which is done by this. So I have current pointing to head, so my current points here. Okay, and my previous is null. Okay, I say while current dot next is not equal to null, current's next is not null condition is true. I say previous is current, so previous now points where current is pointing, so previous comes here, previous not null, no more null. And I say current is current dot next, so current moves to the next pointer, so current comes here. Okay, so if you guys get confused about this, right, that how the references are being copied, think in terms of the fact that whatever value is in the right hand side goes into the left hand side, and that's it. That is what an assignment operator does in programming. So when I say current is equal to head, it means wherever head is goes into current. That is what we did. Okay, when I say previous is null, it means null goes into previous. This is what we did. When I say previous is current, so now previous is pointing to where current was pointing to, which is this. And then when I say current is current dot next, so wherever current dot next is pointing to goes to current, which is this. All right, we check the while loop condition again. Current dot next is not equal to null, so current dot next is this not equal to null, true. We do previous is current, previous is current, previous comes here, current is current dot next, current comes here. Okay, then you do again current dot next is not equal to null, true. You say previous is current, okay, and current is current dot next. Okay, again current dot next is not equal to null, true. Previous is current, okay, current is current dot next. Okay, current dot next is null now, so the loop breaks. So when the while loop breaks, your previous is at second last, current is at last. So I say last node is current. So this is my last node now. My variable last node is pointing to this, and this is my second last node. Okay, so even if you don't use these variables to store the values of previous and current, you still can get the right answer by using just the previous and current variables, but it is not very descriptive. So last node and second last node make it very easy for the person who's reading the code. Okay, all right, and a few extra variables never harmed anyone. Okay, so we are done till here. Then we say second last node dot next is null. Second last node, which is this dot next is null. So this next was pointing to 27. This next is now pointing to null, and this node is lost. This link is lost. So I'm going to delete this link. Okay. So you have two lists now, one with a single node and one starting with head 1, 3, 12, 18 and null. Okay. Then we come here, last dot next is head. Last node dot next was null. It is now head. So the next is now pointing to where head is pointing to. Okay. And then you return last node, which is the new head. So my new head is this, the next of which is 1, then 3, then 12, then 18. So this list is now basically 27, which is the head that is returned, then 1, then 3, then 12, then 18, and the next of 18 is null. Okay, this is right rotating once. We can call it k times to right rotate k times. Okay, so let me just test this. So I have written the code to print the list, and I've also written the code to create a linked list. Now this is variable number of arguments. That is, I can pass as many as integers as arguments here, and all those integers are received as an array to which I iterate and create a linked list. So the order in which I pass the integers here is in the same order that you get the linked list. So let me just show this to you. Node L1 is create linked list. I'll say same values 1, 3, 12, 18, 27. I'm going to say print list L1 and L1. Okay, so running this, so 1, 3, 12, 18, 27. All right, let me just add a few more values, say 9, 0, and maybe somewhere in between 4. So when I run this, okay, you see the order of the values is exactly what I have given in the arguments: 1, 3, 4, 12, 18, 27, 9, 0. Okay, taking back our original example now. Okay, right rotate once. So I say L1. So L1 now is going to store, after rotation, the head of the rotated linked list. Right rotate, okay, once L1, and I'm going to print L1 again. So after right rotation, the second output is the list that you rotate once, which is 27, 1, 3, 12, 18, which is what we saw here. Okay, if I rotate this once more, okay, I get 2 rotations starting from the original list. So you see, your head is now 18. Okay, right rotate once again. So 27 comes here, 1, 3, 12. Okay, if you right rotate once more, there will be one more rotation. Okay, for us, we need to do k rotation. So all I need to do is call this function k times. So I say for int k equal to 0, I equal to 0, sorry, I less than k, I plus plus, I say head is right rotate head and return the updated head. Okay, so if you are given the values 1, 3, 12, okay, after the first right rotation, you will get 27 as the head, then 1, 3, 12, and 18. With the next right rotation, you will get 18 as the head, 27, 1, 3, 12. Then with the next right rotation, you get 12 as the head, 12, 18, 27, 1, 3. With the next right rotation, 3 is the head, 12, 18, 27, 1. And with the final right rotation, you get 1 as the head again, 3, 12, 18, 27. Okay, so you see, for length equal to 5, the number of nodes in this list, for k equal to 1, you get this, k equal to 2, okay, k equal to 3, 4, 5. So when k equal to L, the number of right rotations you make is equal to the length of the list, you get the original list. So the next rotation that you make is going to be 27, 1, 3, 12, 18, same as k equal to 1. So k equal to 1 is the, and k equal to 6 will give you the same set of same final rotated list. Again, if you do this once more right rotation, 18 is the new head, 27, 1, 3, 12, which is the same as k equal to 2. Okay, so k equal to 2, k equal to 7 will give you the same rotated list. Okay, that is to say, k and k percent L will give you the same rotated list, because after L rotations, where L is the length of the linked list, you get the same list. So after L, 2L, 3L rotations, you get the same list. So that is why 1 and 6%, 5, which is 1. Okay, so 1 and 6 will give you the same rotated list. 2 and k percent L is going to be 2, gives you the same list. Okay, so we can do this. So we can do k equal to k percent length of the list. So I can write another function len. So I'll say static int len node head, okay, I'll say int L equal to 0, return L, and I'll say node current is head while current is not equal to null. Okay, current is current dot next. Okay, when you have to iterate the entire list, you say current not equal to null. When you have to go to the last node, you say current dot next not equal to null. Okay, and then do current equal to current dot next, and in this case we increment L to find the length. Okay, so we do k equal to k percent len head. Okay, and we can add this check as well. If head is equal to null, okay, or head equal to next head dot next null, you return the original head. Okay, also if k is 0, okay, after this mod operation you return the original list, because k equal to 0 means no rotations at all. Okay, it means the same original list, and then you can do this. Okay, all right. So now calling right rotate k times, I'll say 3. Okay, so when you right rotate 3 will give you 12 as the head. Okay, right rotate 4 will give you 3 as the head. Okay, on the same list, right? 4 plus L is going to be 9, will give me the same list 3, 12, 18, 27, 1. 3, 12, 18, 27, 1. So 1, okay, 27, 1, 3, 12, 18, and plus 5, 6 is going to give me the same list. All right, if I make this empty, okay, both are going to be null, null. If I make it one single node, any number of rotations will give me the same list. If I say it's a very large value, same thing. Okay, so for a list with 2 nodes, say 3, 2, when you rotate it once, so 3, 2 becomes 2, 3. When you rotate it twice, gets the original list 2, 3, 3, 2 again. Okay, so this is your right rotate using the brute force idea. Okay, moving on to the part where we right rotate optimize the second part. Okay, so writing the list again, so I have 1. Okay, say I need to do k equal to 3 right rotations, for which I will get 12, 18, 27. So for on this list, I do k equal to 3 rotations, right rotate, I should get this. Okay, so from this list you need to get this list. So you can think of moving these 2 nodes at the end of the list. So if somehow these 2 nodes 1, 3, I'm able to disconnect from here and put it at the end after 27. So I have 12, 18, 27, and the next is 1, 3. 12, 18, 27, next is 1, 3, and this is my new head. All right, so I can have similar 5 steps, okay, here, okay, that I find last node. Okay, because after the last node I will have to set this original head. Then second is find new head. Okay, this is my new head. New head for k equal to 3 and L equal to 5 is after the first L minus k nodes. Okay, so k equal to 3, L equal to 5, L minus k is 2. So after the first 2 nodes I have my new head. Okay, for k equal to say 2. Okay, this list will be for k equal to 2, for k equal to 2. So L minus k in this case is going to be 5 minus 2 equal to 3. So you have to move the first 3 nodes 1, 3, 12 after the last node. Okay, so 1, 3, 12 after the last node. So 18 is in this case, in k equal to 2, 18 is in new head. Okay, so then is finding new head, skip first L minus k nodes. Okay, then you say disconnect first L minus k nodes. Okay, so these are the first L minus k nodes, you have to disconnect them. So set basically the next of this node 3 to null in case of k equal to 3, set next of 12 null in case of k equal to 2. Okay, because you want the next of the last node to be null. Then the part is move first L minus k nodes to end of list. Okay, and then E return new head. All right, so in my optimized version, which is going to be right rotate 2, so this is O nk. Okay, because this is on, okay, and we are calling it k times, so this is onk. Our optimized version, which is 2, will be running in on, right? We need to add this check if list is empty, list has single node, return the same list. We need to do this. If k becomes 0, we return the original list. Okay, then we do our rotation. Okay, the first part is finding the last node, which we can do from copy from here. Find the last node. This is I rotated one for now. Finding the last node is we don't need previous in this case. Okay, because we don't need to find the second last node, we just need to find the last node. Okay, then we need to find new head, which is after skipping the first L minus k nodes. Okay, find the new head. So for int I equal to 0, I less than L minus k. So let me just calculate the L as length of head. Okay, and I get k percent L. Okay, I less than L minus k I plus plus. Okay, I will keep my current at head. I'll say current is current dot next. Okay, I will keep my I equal to 1. I'll explain you why when I try run this. Okay, I'm finding the new head. So node new head is the next of my current. Okay, because when I skip the first two nodes, my new head is this 12. Okay, then disconnect. Okay, first L minus k nodes. Okay, so my new head is here, my current is at 3, so I can say current dot next is null. So I'll say current dot next is null. Okay, and then I need to move first L minus k to the end of the list. So the next of last node becomes the original head. So move first L minus k nodes to the end of the list. So I'll say last node dot next is head. Okay, and then I return the new head. So return. Okay, all right, let me just dry run this and show this to you. So again, I have to get this list. This is my original list 1. All right, step 1, find last node. So we start with current equal to head. Current is at head, so this is my head. Okay, current is here. Okay, while current dot next is not equal to null, I do current is current dot next. So if the next of current is not equal to null, I do current is current dot next. So current moves to the next pointer. Current dot next is again not null, current moves here. Current dot next is still not null, current moves here. Current dot next is still not null, current moves here. Current dot next is now null, so the loop breaks. When the loop breaks, your current is here, so you create a new variable last node, which is referencing to this last node current. Okay, this is done. Then you find the new head. For finding the new head, you move current back to head, so current now points to this again. Okay, you say I equal to 1, I is less than L minus k, I equal to 1, L minus k, this is k equal to 3, L equal to 5, L minus k is 2. So the stopping condition for the for loop is I less than 2. 1 is less than 2 true, you do current equal to current dot next, so current comes here. Okay, in the for loop, I plus plus happens, I becomes 2. 2 is less than 2 is now false, this for loop breaks. So your current is here. That's why we start with I equal to 1, because when you're setting current to head, you are already at the first node and you have to skip the first L minus k nodes. So if you start with 0, you will count one more node, so we'll end up here. Okay, that's the idea. Then you say new head is current dot next. So current's next is my new variable new head. Okay, so I have pointers current here, new head here, last node here. Okay, then I say current dot next is null. So current's next is null. So that is how I'm disconnecting these two nodes. So this next is now null. Okay, so we have two lists, 1 3 null and 12 18 27 null. Then I say last node dot next is head. Last node dot next was null. Last node dot next is now head, because head is pointing here. So basically what happens, we have 12 18 27 1 3 and null, and our pointers are, we last node is here. Okay, our current was pointing at 3, current is here. Okay, we had head pointing to 1, so head is here. Okay, we had one more pointer, new head is at 12, so new head is at 12. Okay, these are the 4 pointers we have for this list right now. And then we return new head. This is the new head returned. So you get 12 18 27 1 3, 12, 80, 27, 1, 3, the list that you want. Okay. All right. Testing this now. So right rotate 2. Okay. All right. Let me just do this thrice for 1, 3, 12, 18, 27. Okay. Running this now. Right rotate thrice will give me 12, 18, 27, 1, 3, which is what I want. Okay. Right rotate 4 times will give me 27 as the 3 as the new head. Okay. Yes, 3 comes here on the other side. All right. Right rotate 4 times gives me 3 as the head. Right rotate 2 gives me 18 as the head. Rotate 2 gives me 18 as the head. Okay. Right rotate once will give me 27 as the head. Okay. And right rotate 1 plus 5, which is 6, will give me the same list. Plus 5, 11 will give me the same list. Okay. Or you can say plus 3 times into len of L1. Okay. Will give you the same list, 27. Okay. All right. Or you can make this like 20 times. Same thing. Okay. All right. If I make this a single node list, always the same. I make this null, always the same. I make this 2 into 3. So this, if this is even, so this is 2 plus 20 times, right? So this is going to be the same list. If this is odd, 1 plus 27 times, it is going to be 3. Okay. All right. So this is your right rotate using optimized method. Okay. Making L1 3 times again. Okay. One more thing is I've already uploaded a video for left rotate. Okay. And we are doing right rotate in this case. The thing that I want you to note here is you just need to know one rotation to perform the other. What I mean to say is if I have the same list, just writing the values 12, 18, 27. Okay. You have to right rotate. Okay. And with 1, 3, 12, 18, 27, if you left rotate. Okay. So for K values 1, right rotate you get 27, 1, 3, 12, 18. Then again you get 18, 27, 1, 3, 12 for the next right rotation. For next you get 12, 18, 27, 1, 3. For next right rotation you get 3, 12, 18, 27, 1. And then for the next right rotation you get 1, 3, 12, 18, 27. Okay. And this has L equal to 5, L equal to 5. Okay. Again for K equal to 1, left rotate. So this goes here, this goes here, this goes here, this goes here, this goes here. So one goes on the other side. So this is 3, 12, 18, 27, 1. For next left rotation, this 3 goes to the other side. 12, 18, 27, 1, 3. For next left rotation, 12 goes to the other side. So 18, 27, 1, 3, 12. For next left rotation, 18 goes to the other side. 27, 1, 3, 12, 18. For next left rotation, we have 1 as the new head. Okay, same. Okay. What I want to say is if you know how to rotate right or rotate left, you can form the other one. Okay. So for a given value of K right rotations is the same as L minus K left rotations. And same L minus K right rotation is same as K left rotations. That is, you can see 1 and 4 are the same. 27, 1, 3, 12, 18. 2 and 3 are the same. 18, 27, 1, 3, 12. Okay. 3 and 2 are the same. 12, 18, 27, 1, 3. And then 1 and 4 are the same. Okay. So if you consider this value as K, so in this case, K equal to 1, L equal to 5, L minus K is going to be 4. So 1 and 4 are the same. When you consider this value as K equal to 2, L minus K is going to be 3. So L minus K is going to be 3. Okay. So you can remember this. Okay. So if you know how to right rotate a list K times, in order to do left rotation K times, you do L minus K right rotations. Okay. All right. So this was your Java program to right rotate list K times. And I hope this was helpful. I hope I did not go way too deep into this video went very long, I guess. So I hope this was helpful and you like this video. So if there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments. And you can also let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.